Hello everyone, I'm Mr. Furlong, and today we're talking phylogeny. In this video, you're going to be hearing a lot about phylogenetic trees and cladograms. They both do very similar things, but there is one small difference between them. They both do show evolutionary relationships among lineages. The one difference is that a phylogenetic tree can also show the amount of change over time, and this would have to be, of course, calibrated by a fossil or by a molecular clock. So now, what was a cladogram is now a phylogenetic tree. But it's okay if you use these two words interchangeably. We know that traits are either gained or lost during this process of evolution, and we can use those gaining or losing of characteristics to construct our cladogram or our phylogenetic tree. But you have to remember that even though we make these things, they only represent a hypothesis, and of course they're constantly being revised based on new evidence. So let's take a look at the interpretation of these. Shared characters can be present in more than one lineage. So for instance, we see that with that bottom four group of bears, all four of them share a common characteristic or derived character. But when we look at the bottom two, the Western North American brown bears and the Asian brown bears, they have a shared character between them that the European brown bears and the polar bears don't have. Now, these shared derived characters can indicate common ancestry, and typically we would see that where we have these brackets. So that first common ancestor of those bottom four, that would be an older species, it's farther back in time, compared to the more recent common ancestor of the North American brown bears and the Asian brown bears. Oftentimes you will see what's called an outgroup. They represent the lineages that is the least closely related to the remainder of the organisms in the phylogenetic tree. In this case, the outgroup are the black bears. Now, certainly all five of these bears share a common ancestor, but that common ancestor appeared long ago compared to, say, the common ancestor of the remaining four. We can also use cladograms to illustrate that speciation has occurred. The nodes on the tree represent the most recent common ancestor of any two groups or lineages. So wherever you see a node, again, that's where a common ancestor would be. Phylogenetic trees and cladograms can be constructed from morphological similarities of living species and fossil species. So those would be things like their anatomy, for instance. We can also use DNA and protein similarities as well. In fact, DNA and protein similarities do provide a more reliable and accurate evidence than the morphological traits do. So this is typically the preferred method when possible. So for instance, here we see a comparison of amino acid sequence and hemoglobins from 8 different mammals. We would simply look to see how many differences there are between each of these, and from that we could build a cladogram. Building these cladograms or phylogenetic trees and interpreting them is a very important skill that we're going to be doing a lot of, and I'll see you in class.